Hi, welcome back to another video. So today we're going to be talking about expressions and how to solve them specifically, because this is a tool that we're going to be using quite a lot from this point on. Like if you're going to look at the exercise videos, we're going to see that basically every exercise is going to need at least some like a few steps of solving systems of equations. So this is quite important to actually know. Now let's get right into it. We can start by looking at what happens if we have two terms. So if we have two terms, we have, generally speaking, like four possible cases. So the first possible case is this, that we just have 3x plus 5, for example, or basically what we're going to have is a linear function. So something times x plus something equals 0. Now what do we do with this information? Well, we want to solve for x, so we're going to take the term that doesn't have an x next to it to the other side. So we're going to get 3x equals minus 5. And then we're going to divide by the term that we have next to x. So in our case, it's 3. So x equals minus 5/3. And if you want to check if you got the correct solution, plug this number into the original equation. So what we're going to do is we're actually going to do that. So we have 3x minus 5 equals 0, and then we have 3 times minus 5/3 minus 5 or plus 5 equals 0. So the 3 in the denominator and the times 3 are both cancel each other out, so we have minus 5 plus 5 equals 0. And then, 0 equals 0. So this is the correct solution. Now, what happens in the other case? So, say that we have, this is the second example, so that we have x to the power of 2, or x squared, plus some term with x. Well, we're going to use the fact that anything multiplied by 0 equals 0. What do I mean by this specifically? Say that we have a series of multiplications. So let's say a times b times c times d equals 0. When is this actually going to be 0? Well, it's going to be 0 when any one of these terms is actually going to be 0 as well, because anything times 0 is 0. So if a is 0, then this is true, or if b is 0, or if c equals 0, or if d equals 0. Now, what we want to do is ideally just transform this original equation into a series of products. So something times something times something, and then solve for when each of the individual terms is going to be equal to 0. In this example, they have a common term, which is x, so we can factor it out. So x, and then we have 4x minus 1 equals 0. Now, since 4x minus 1 equals 0, this is going to be equal to 0 either when the first term is equal to 0 or when this first parenthesis is equal to 0. So if x is equal to 0, so that's our first solution, or if 4x minus 1 is equal to 0, and in this case we get again the very first case again. So we just add 1 to both sides, and we get 4x equals 1, and divide by 4, and we get 1/4. Okay, great. So that's how you would solve equation that has two terms and has an x squared factor and an x factor. This is a bit of a special case. So we have an x squared, and then we don't have anything with x related next to it. What do we do in this case? Well, this is actually a very specific formula, and the formula is a squared minus b squared equals a minus b times a plus b. In our case, we're going to see that this is actually used quite a bit. So here we have the classic example. X is our a, and it's increased to the power of 2. And then 1, well, that's also to the power of 2. So we can actually expand it or change it into this form, just a second, like this. So x minus 1 times x plus 1 equals 0. And then we're going to use the same thing that we used previously. So we know it's going to be equal to 0 when each of the terms or each of the parentheses in this case are going to be 0. So either when x minus 1 equals 0, in which case we have x equals 1, or when x plus 1 is equal to 0, in which case we have x equals minus 1. Why? Well, if we insert 1 here, we have 1 minus 1, which is equal to 0. And then 0 times whatever this is, well, in this case it's going to be 2, is still equal to 0. So yeah, we just basically use the fact that if we multiply anything by 0, we get 0. Now, what we have here in the last case for two terms is a expansion formula. So what happens if we have two terms that are instead of to the power of 2 and with a negative sign in front of them? What would be the general case? Well, the general case would be this one. And there is something you do need to be aware of. If you have a plus sign between them, like this, what you need to be careful is that the plus sign the formula only works if the power that they are raised to, so n in this case, is odd. So n is odd. Is the only way we can have this formula here. Now, how does the formula go? Well, it's quite simple. We start by a plus b, so we factor a plus b out, and then we just have a to the power of n minus 1, and then we are just going to alternate plus, minus, plus, minus. So here was plus, now we're going to have minus. And then we're going to decrease the power of n by 1 each time and increase the power of b by 1 each time. So here we have a to n minus 1 and b to the power of 0, which is equal to 1. Now we're going to have minus, because we had a plus sign before, a to the power of n minus 2 and b to the power of 1. Then we have plus, and it's going to be a to the power of n minus 3 times b to the power of 2. And it goes so on and so forth. Eventually you get to minus a to the power of 1 and b to the power of n minus 2 plus b to the power of n minus 1. That's how the formula goes. And it's always going to be like this, because this one, the last term, b to the power of n minus 1, has to be positive, because when this is the term that has the highest power of b, so when we multiply it with this b, we have to get b to the power of n. So this would be b to the power of n, and because this one has a plus sign, it has to be positive, so the one before it has to be negative. Okay, now what about the negative formula? So a to the power of n minus b to the power of n. Here n can be even or odd, so it doesn't matter. So we have a minus b, and then we just have only plus signs. So it's the same thing, except instead of alternating between positive and negative symbols, we're just gonna have only positives. So a n minus 1 plus a n minus 2b plus a n minus 3b squared plus, and so on and so forth. bn minus 2 plus b to the power of n minus 1. That's pretty much it. All you have to really know about it. So yeah, these are the two formulas, and these are all of the examples if we have two terms of everything you can do. This one is actually shouldn't be used that frequently. Sometimes you can use them for some specific exercises, but we're gonna see that in general we're gonna be using these three the most. Now, what happens if we have three terms? If we have three terms, then we have the so-called Vieta's formulas. So there are two formulas that we can use. So this is the general case where a equals 1, or sorry, not the general, the specific case. How does this one work? Well, it works in a very specific fashion. So what we want to do is we look at some symbols and then try to deduce the signs. So if we look at this one, we have a positive sign here and a positive sign here. We're always going to start with the same first step. We're going to write two parentheses, one next to the other, and the first term is both, and this a equals 1. This is the one that I'm talking about. So x squared has 1 next to it. Okay, so we're gonna start with x on each side here, and then if the second sign, so the one next to the number that has no x's, is positive, then either both of these are going to be positive or both of these are going to be negative. So if both of them are positive, then, well, if the first sign here is positive, then both of them are going to be positive, and if it's negative, both of them are going to be negative. If we have a minus sign here, then one of the terms here is going to have a plus and the other is going to have a minus. So these are the rules. So if we have a x squared plus bx plus c, where a, b, and c are some numbers, and we have c is more than 0, we have two cases. We have b is less than 0, in which case we have x minus as our template, and if b is more than 0, so like it is in our case, we have this template. And the other is if c is less than 0, then we have this template. Doesn't really matter if we switch the minus and plus around, so it can also be like this, whichever one you prefer. Generally speaking, I prefer the first one. Okay, so this is how you determine the template that you have. In our case, c is more than 0 and b is more than 0, so we're gonna have two plus signs here. Now we're trying to find out a combination of numbers that multiplies into 15, so two numbers that together when multiplied give 15, and when summed together they give plus 8. Okay, so how can we get 15? 1 times 15, well, 1 plus 15, so we just look at these signs here. We can only have plus signs, so it's just going to be plus signs here. If we had, for example, a negative sign, we might have had to look what if we have minus 15 plus 1, or minus 1 plus 15, for example. But since both of them are positive, we'd only have a very simple case. Now, what about the next option? Well, 1 times 15, and how else can you get 15? Well, 3 times 5. And it turns out that 3 plus 5 is equal to 8, so this would be our solution. So 3 and 5. And that's how we would transform the terms that we have. Okay? Like this. Now, what happens in some other cases? Well, for example, if we had two negative signs here, it would give us a different template and we'd have to test more numbers. But since that's going to be explained in the actual exercise videos, let's just move on right now. Okay, so this is a bit of a more general case, so where the number in front of x squared, so this is a, we usually denote the number before x squared as a, is not equal to 1, but is a bit of a different number. Well, the same thing applies for our template, so since we have positive signs here, we're gonna have a very similar case. So we have x and x here, and then two plus signs. But here's the difference. The difference is that this number here is going to be also split into two terms. So either 4 and 1 or 2 and 2. So the terms together should multiply into 4 in our case. So we can either have 4 and 1, or we can have 2x and 2x. Okay? And then we're gonna look at the same thing. So we're trying to see how we can split 9 into two parts that when added together, when multiplied together, they give 9. And when added together but multiplied by these terms here, give 12. Okay, so let's look at the first case. Let's say that we have 1 times 9. Well, we can either look at this example, and in which case, the first case, we could have, for example, 4 times 1 plus 1 times 9, or 4 times 9 plus 1 times 1. So the order does matter. None of these are equal to 12. Okay, so this one is 13, and the one below it is 37. So the first example is a no-go. We can just delete it. Now we will want to look at the second case. So with plus 2 and plus 2. Or, wait, my bad, actually. There's one thing that we do have to check. So we can also have 3 times 3. So 9 can be made out of 3 times 3. So yeah, we have to check that one as well. So 4 times 3 plus 1 times 3. Well, that's not equal. Is it? So 4 times 3 is 12 and 1 times 3 is 3. So we get 15. So yeah, that also wouldn't work. So in this case, because 15 isn't equal to 12. So we can now rule out the first case. And because both of the terms are 3, the order doesn't matter. So because we had 3 times 3, it doesn't matter if we multiply the first 3 by 4 and the second one by 1, or vice versa. So we want to see if we can solve it by using 2 and 2. Well, let's look at it. So if we have 2 and 2 times, with a plus sign in front of them, 9 and 1, well, we're gonna get here 18 plus 2, which is equal to 20. And that's not gonna work. And again, since 2 and 2 are equal terms, the order doesn't really matter. Now, what about the other case? Well, 3. So if we, instead of 1 times 9, we use 3 times 3, well, then we have 2 times 3 plus 2 times 3, which is 6 plus 6, and that does equal 12, which gives us the solution. So we have plus 3 plus 3. And we see that this actually becomes 2x plus 3 to the power of 2. So yeah, this is a bit of a more nuanced case, and the majority of the times you're actually going to use the so-called quadratic formula. So how does the quadratic formula work? Well, you look at the terms that you have here. So 4, 12, plus 4, plus 12, and plus 9. A is your plus 4, B is your plus 12, and C is your plus 9, okay? And then you use this formula. So x1 and 2 equals minus b plus minus the square root of b squared minus 4ac divided by 2a. So that would give you minus 12 plus minus the square root of 144 minus 16 times 9, right? So 4 and 4, yeah. 16 times 9 divided by 8, okay? And if we multiply 16 by 9, we are going to get, so 10 times 16 is 160, minus 16 should be 144. So this is actually equal to, so 1, 2, minus 12 plus minus the square root of 0, which is just 0, and this is our solution. So minus 12/8, or if we divide by 2, we have minus 6/4, and this is minus 3/2. Okay, so this is our solution. And if we see, it's actually the same as the one we got here, okay? Because we would get 2x plus 3, and if we insert 3/2 here, we would get minus 2 times 3/2 plus 3, and we get 0, which would be the correct answer. But we're gonna expand on this formula a bit more later. Now, the last case that we have is just the simple formula that we also know. So a plus b to the power of 2, which equals a squared plus b, 2ab plus b squared. And in our case, here we have a as x, and actually here should be 4. So 4. So that's 2 times 2. This is our b, and here we have b squared. So we have a plus b squared, or in our case, x plus 2 squared. This is another example, and yeah, lastly, we have what if we have 4 terms? Well, if we have 4 terms, we have 2 formulas that you need to remember. So we have a plus b to the power of 3 and a minus b to the power of 3. So the first one is a to the power of 3 plus 3a squared b plus 3ab squared plus 27, or sorry, plus b to the power of 3. And in the second one, we have the same thing, except if we have a minus sign. So if we have a negative sign here, we're gonna have one here and here, okay? Because here b is to the odd, or odd power, so the negative sign doesn't get cancelled out by the even power. Okay, that's basically the whole thing that you need to know. So if we use this formula here, we have Rx is, or Ra is x, and Rb is 2. And if we check, so this should be 3 times 2 times x squared, which is cool because we have 3, and we have a squared, which is our x squared, and we have b, which is our 2. Here we have 3 times 4 times x, so this is our b squared, which is our 2 to the power of 2. And yeah, the formula fits, so x plus 2 to the power of 3. And now lastly, we have a new case. So if you have 4 terms, sometimes you can factor out something from the from 2 of the terms and something else from the other 2 terms, and then factor out the new common term. So this is a bit hard to explain, so let's just demonstrate it here. We see that the first and the second terms share x to the power of 2. Let's factor it out. So we have x squared times x plus 2. And now the second 2 terms contain both 2. So let's just factor 2 out, and we have x plus 2 here. And now note that the 2 terms have a common term again, which is x plus 2, so we can factor that one out. So x plus 2, and then we get x squared plus 2. This would be the last example, and then we solve for when each term is equal to 0. So x equals minus 2, and this one doesn't have solutions. Doesn't have solutions in the domain of real numbers. Okay. And that's basically what can happen if you have 4 terms. Now lastly, we're gonna mention the binomial theorem. The binomial theorem is a bit of a specific case because some teachers explain it very early on. For example, our teacher explained it only in the 4th year, of high school, while I have some students that already have to know it in the very first year. So we're gonna mention Pascal's triangle. So you start by 1, and then at the edges there's always going to be 1s. Okay, so the next term we have 2 edges, so 1 and 1. And then the third row, which has 3 elements, also has 2 edges, so 1 and 1. But what about the term in between? The terms in between are the sum of the 2 terms above it. So in this case, 1 plus 1 is 2. Then we have, again, edges are 1s, and then 1 plus 2, so 1 and 2 are going to be 3, and 2 and 1 are going to be equal to 3. Then we have, again, 1 and 1. These two become 4. 3 and 3 become 6. 3 and 1 become 4. And then you move, and so on and so forth. So 5, 10, 10, 5, and 1. And it would just expand like that. Okay, so that's Pascal's triangle. Now the reason we have it is because we're going to use it here. Say you have a plus b in parentheses to the power of n. How do you solve this? Well, it's basically going to be the same as we had with this case here, where the coefficient of a, the power of a decreases by 1 each time, and the power of b increases by 1 each time. So you just write the same thing. So you have a to the power of n plus a to n minus 1 times b plus a to the power of n minus 2 times b squared plus, and it goes on, so on and so forth. And what happens? Well, if you have the terms, we have to write some numbers here. So this one would have a number, this one would have a number, this one would have a number, and so on and so forth. And the numbers are going to be equal to the corresponding row of Pascal's triangle. So if here we have n, this goes like this: 0, 1, 2, 3, 4. So let's say we have a plus b to the power of 3. We are going to look at the third row, which is, so this one, 3, and it has 1, 3, 3, and 1. So we're going to have 1, 3, 3, and 1. And the first term is going to be a to the power of 3. The second term is going to be 3a squared b. And the third one is going to be 3ab squared, or ab squared, sorry. ab squared. And last one is going to be b to the power of 3. So that's how you would expand it, and that's basically how the binomial theorem is gonna work, and that's a very, very brief explanation. So, but should be enough for you to solve exercises. Okay, and if there's a negative sign here, then the terms would alternate once more. Okay, so yeah, that's basically all you need to know, and I will basically see you in the next video. So goodbye.